Okay, fine. Today we'll discuss standard template library. We'll discuss some of the uh, inbuilt functions or classes or containers, whatever is available. Okay. Today we'll focus on strings only. Okay. Have you gone through the PPT? I had shared it with you.
Yes, sir.
आपने देखी है PPT?
Yes,
I
sir.
assume आपने देखी होगी. Okay.
Yes, sir.
Standard template library is now a part of C++. It was introduced quite late, and it's something very powerful. It's a set of components, or you may say data structures and algorithms and iterators. So we'll be discussing its introduction, what are the benefits, what are its components, relationship between the components, what are the different types of containers, sequence containers, associative containers, derived containers, and then algorithms we have, and iterators, function objects, and finally allocators. These are the different things we'll discuss today about standard template library. So these are the two persons, Alexander Stepanov and Mengele. They had basically developed this STL, which was later on became part of the C++. What are the benefits now? It reduces the development time. I think I had told you a few days back that there are certain algorithms and certain data structures which are readily available. You need not to reinvent the wheel.
Yes, sir.
For example, stacks are there, queues are there, linked lists are there. They are already inbuilt. So whenever you have to apply any of these data structures, you can depend on standard template library. You need not to create your own list, your own stack, your own dynamic array also. We call it vector here. Okay. So it reduces the development time. You can straight away focus on applying those data structures instead of constructing them from the beginning, because they are already written and they are well debugged, they are error free. It improves the code readability. However, I don't agree with it. It makes the code a little difficult to understand because of all that cryptic code. Oh, okay. So, but definitely it reduces the code also because it is typeless programming. We are not dependent on types here. Robust, you can apply the algorithms on, you can use the data structures on variety of types, data types. Not only confined to elementary data types, you can have your own data types also. You can use classes, structures, or whatever else is there. And these data structures grow automatically. You don't have to depend on pointers now. Like when we declare an array, its size is fixed. When we declare a pointer, if you have allocated memory to a pointer, then again it becomes fixed. But in case of standard template library, the data structures available in standard template library, they are dynamic. They can grow automatically. Code is portable. You can port to any type of environment, like Windows code can run on Linux and somewhere else also. That's not an issue. And reusability. You can reuse the code anytime. So it is a general purpose templatized classes. I told you these are classes, means they are data structures, and functions means they are algorithms. One algorithm we have already discussed, quicksort. So there are many others. For example, you can, if you want to replace something in a string, there is an algorithm for that. You want to perform binary search, there is an algorithm for that on any type of data. So the collection of these generic classes and these generic functions is collectively called standard template library. And these components, all these components are defined in std namespace. So when you are writing using namespace std, it means you are including STL components as well. There are several components available in STL, but at the core are three main components, which are containers. Containers means they will contain the data. For example, a stack, a queue, a linked list, all these are containers. Then algorithms, which will work on the data. Like quicksort is there, binary search is there, mapping is there, so many other algorithms are there. And finally, iterators. Now, algorithms will use iterators to manipulate data stored in containers. We'll see their relationship just now here. As you can see, this is a container. It may have different objects. These are the different algorithms which will work on these objects through the iterators. For example, if you want to traverse a linked list, an iterator is there. If you want to traverse an array, an iterator is there. If you want to traverse through a string, an iterator is there for that also. So what is a container? Basically, it's an object that actually stores data. As I have told you that algorithms will work on data stored in containers, and those will work through iterators. So it is a way how the data is organized in the memory. So these STL containers are implemented by template classes and therefore can be easily customized to hold different types of data. So the three major containers are, though there are many, but three major are sequence containers, in which the data is stored in a sequence, associative containers, where is some related keys related, and derived containers, which are derived using sequence or associative containers. So under sequence, we have three containers: vectors, which are basically dynamic arrays; DQs, double-ended queues, you already know this; and list. These are the sequence containers because the data is stored in a sequence in these. Then we have associative containers, where some keys are attached with the data. We have sets, multisets, maps, and multimaps. And finally, we have derived containers, which are derived using these containers: stacks, queues, and priority queues. So sequence containers, in this, the data is stored in a linear fashion. And each element is related to other elements by its position along the line. And they all expand themselves to allow insertions, and those insertions may be in between, those may be at the beginning or at the end, anywhere. So there are three sequence containers we have already discussed: vectors, lists, and DQs. So this is how data may be organized in a container. There is a starting position. These are the iterators, begin and end. Through these, we'll iterate through the elements and then reach the end. So the data is organized in a linear fashion. So what are the basic difference between these three? Vectors. When you want to implement random access, vectors are very fast. Lists are slow because we will have to traverse the different elements. DQs are again very fast. If you want to do any kind of insertion in the middle, then vectors are slow because shifting will be required. Linked list is fast because no shifting is required. DQ is again slow because again shifting is required. But if insertions or deletion at end are to be done, then vectors are very fast, lists are very fast, and queues, since insertion deletion can be done from both the ends, so it is very fast, right? So these are the containers. Associative containers are designed to support direct access to elements using keys. Like you might have used heaps. Sir ने heaps करवा दिया आपको?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Heaps के बाद hashing भी आती है. Hashing करवाई?
No,
No,
sir.
No, sir. No, sir.
चलो ठीक. So there are four different types of associative containers: sets, multisets, maps, and multimaps. All these containers store data in a structure. We call it a tree, right? Which facilitates fast searching, deletion, and insertion. These are very slow for random access and inefficient for sorting. Random access cannot be applied on these. How these are implemented? With every data item, a key is associated. So using that value of key, we insert, delete, or search the data. So what's the major difference? A multi-set allows duplicate items while a set does not allow, right? Multi-set may have duplicate items, but in case of sets, duplicate items are not allowed. Similarly, maps. So they are used to store pair of item. One is key, the other is called the value. Values can be implemented using keys associated with them. Values may be manipulated using the keys associated with them. The values are also called mapped values. As I told you, with every value, with every data item, a key is associated. That's how they are differentiated. Now map allow only one key. A simple map will allow only one key, whereas a multi-cap will permit use of multiple keys. Then we have derived containers. These are also known as adapters. These containers do not support iterators. इनमें iterator नहीं हो सकते. You can't move from one position to another. Like in case of stack, you can only have access to the top element. You cannot have access to in between elements. So these basically support two functions, pop and push, for implementing deletion and insertion operations. So STL provide three derived containers. We had discussed it: stacks, queues, and priority queues. Then we come to algorithms. So algorithm is the procedure that is used to process the data contained in container, as I told you earlier. Algorithms will use iterators to manipulate data stored within containers. There are different types of algorithms, like we may have algorithm for sorting, for initialization, for searching, or for merging the data items. So these algorithms are implemented using template functions. We had in the class, we had discussed a few template functions like finding minimum or finding maximum and so on. So when we have these STL algorithms, it saves a lot of time, a lot of effort is saved. These can be categorized on the basis of nature of operation performed by them. These may be retrieved, these may be for retrieve or non-mutating algorithms, means they are not modifying the containers. For example, when you are counting or you are doing conditional count or you are equating or you are finding mismatches, because these four are not modifying the contents of a container, so these are non-mutating algorithms. Mutating are which will modify the containers. For example, copy, container will be modified, this data stored will be modified. Fill, remove, rotate, or replace. All these will modify the data stored in containers. So these are called mutating algorithms. Then we have sorting algorithms, sorting and searching. We have quick sort, binary search, make heap, and pop heap. Similarly, set algorithms are there. What's the difference between two sets of data? What's the result of union between two sets? And then there are relational algorithms, which is the maximum element, which is the minimum element, and so on. Then we have iterators. Iterators behave like pointers and used to access container elements. So when you want to shift from one container element to another, we can use iterators. So these are often used to traverse from one element to another. Iterators are handled just like pointers. We can increment or decrement them. Iterator connect algorithm with container. I had told you that algorithms will use iterators to manipulate data stored within containers. So there are different types of iterators also, depending on different types of containers. So we have random access, bidirectional, which can go in forward direction or backward direction, and then forward only. So we have input, which will read elements from container. It can move only forward. Output, it will write elements to container. Again, it can move in one direction only, that is forward. Forward combines input and output, but it retains the position. Multipass, it can pass through sequence twice. Bidirectional, it can move in both the directions, like forward, but can move backward as well. Then we have random access. When we want to go to a random element within the container, then we use this type of iterator. So you can see there, input, output, these all these first four are linear, last one is random. Input and output can move in forward direction only. Forward will definitely move in forward direction only, and backward can move forward and backward both. Sorry, bidirectional can move in forward and backward both directions. Then we have function objects. So it is an object that has been wrapped in a class so that it looks like an object. The class is templatized so that it can be used with different data types. Function objects are often used as arguments to certain containers and algorithms. For example, in this case, if you look at this, we had discussed this thing in class also. Suppose you are using quick sort. What will you provide? You will provide the array which is to be sorted, size of the array, size of each element. Then there will be a function which will compare different types of data. So for different type of functions, data, there will be different type of function. I hope you remember we had discussed it, that for integer there may be a different function, for strings there may be a different, for structures there may be a different function, and you just have to pass the address of that function in the quicksort algorithm. So those functions are basically function objects. So function objects may be binary or unary. Binary when they are comparing something, unary maybe for some other reason. Like here, divides, it will, these are the function objects inbuilt in the STL. Divides, it will divide two values, equal, it will tell you whether two values are equal or not, greater, logical and multiplies. These are the function objects available within STL. Then we have allocators. So allocators manage memory allocation for a container. Since the STL defines a default allocator that is automatically used by the containers, we need not to, programmers need not to worry about this. So then we have a summary. Over the next few lectures, we'll be discussing different types of components of STL. Like today, we'll discuss strings. ये समझ में आ गया जो कुछ अभी तक डिस्कस किया?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes.
Today we'll
Yes,
discuss a little bit about strings. आपने थोड़ा बहुत यूज किया strings को. And the container, these STL components are very interesting. I'll show you how. So let it be string S1. This is okay. This is a sample string to demonstrate use of string. Fine. Suppose this is the string. Now, what happens in this case? Let us print it first. Cout S1. Let us print its size. S1 dot size. Now, what happens in case of strings? The memory allocated to this S1 object of string will not be this much only. There will be some additional memory allocated so that if needed, some more data may be accommodated. But if it goes beyond that, then it will automatically adjust its size. So there are two functions. S1, it will tell you the size of the string which is stored in this S1. Capacity will tell you how much more data can be stored without modifying the size. So let's just run it. So look here. It is 63 is the size and 63 is the capacity. I'll increase it one more. I'm just putting a space here. Let's see what happens then. See, I added just one space. अब कितना हो गया?
79.
64
79.
is the size, but its capacity is 79 now, right? Okay.
Yes, sir.
Then next, we can create another string from it. String S2 is equal to S1. And then let's print that string as well. Same string create ho jayegi. And it can be done using two different methods. One is by assignment. Second is by constructor, by calling the constructor. For example, here, we will pass it as a parameter and still it will work. Is it clear? बच्चे, is it clear?
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
साथ साथ बोलते रहो, मुझे पता लगता रहे समझ भी आ रहा है. Okay, fine. Let's move further.
Okay, sir.
Then there are iterators also. String iterator. I'll declare it. Right? I'll write it is equal to s1 dot begin. Now the iterator, since this iterator belongs to string class, so we'll have to use this string scope resolution operator, iterator, and this is the iterator variable. So now iterator is pointing to the beginning of the class, beginning of the string class. So if I modify it, it is equal to t. And something important, something important here. This iterator is for S1 only, as you can see here. S2 will remain unaffected. What I have done, at the beginning position, I have stored t. Like here, it is small t. Now it will become capital T. Let's run it once again. Let's print the value of S1 and then run it once again. So you can see the difference. Here it is small t. Because of through the iterator we have modified the value, so it is capital T now. Is it clear?
Yes, sir.
Through the iterator you can move through different elements of the string. So we have discussed iterators, we have discussed constructor, now concatenation. Okay. Now let me write something else in the string2 class. Hope it helps in learning strings, right? So we have two different strings. I'll declare a third string and use first and second, and then let's print the third string. This is how we concatenate. So here's the third string. This is a sample string to demonstrate the use of container. Hope it helps and so on, whatever else is there. So its total size is 97 and its capacity is 111. Is it clear? We had modified the second string. Its size is 33. It means there are 33 characters and capacity is 47. You can go on adding more characters to this up to 47. The size won't change. The moment you will increase number of characters beyond 47, its capacity will further increase. That's how it works. Okay. And next concatenation we have discussed. Now substring. Okay. What I can do, let me declare another string s4 is equal to s1 dot substring. There are two different methods. Let us do it first through constructor. Let it be s1. We can specify 8, specify 15, see what will happen. It means copy 15 characters from 8th position onward. S4 will be created from S1 by extracting 15 characters from 8th position onward. So 8th position is A. A sample string, it is copied here. So its size is 15, its capacity is 15. If we increase it by 1, say I'll make it 16. Let's see what happens then. So it's a sample string. Usme space bhi aa gaya. Size is 16, but its capacity will increase to 31. Earlier both of them were 15 only. Okay. Then we can use another method, for example, string s5 s1 dot substring. Again, let it be from 16th position and 20 characters. First is the position from which you want to extract the substring. Then next is how many elements you want to extract from for making the substring. So let's print it again. Aljit, अपना mic off करो. Okay, have a look. So in the second case, we have copied 20 characters. So it is copied from this point onwards, and it will copy how many? How many we had written? 20. So it has copied 20
20.
characters from this point onwards. Size is 20, capacity is 31. Whatever we have discussed till now, is that clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, good, good. Then next we have find
Yes,
and
sir.
replace. Next we have find and replace. Let's use third string to discuss how to implement find and replace. What's the third string? Have a look once again. This is a sample string to demonstrate the use of string container. Hope it helps in learning strings. Okay. So string is appearing thrice here. Clear? String is
Yes, sir.
appearing thrice here. So we'll see how to replace first instance of string. Then we'll see how to replace all instances of string. So we'll write string S4. This is the string that we want to replace. We'll write S3 dot replace. From where we want to replace, right? It will be from the beginning, right? We can write 0. The string that we want to size, okay, then is size. How many characters we want to replace? S4 dot size will write. And then the string which is to be replaced there. Let us print this third string once again. And let's see whether it's been replaced or not. Oh, okay. Wait. I made a mistake here. Here, let me write sample. Okay. So what will happen? We are looking for this string and we want to replace it with sample. Okay. Let us just check it. I think there is still something missing. It's not been replaced, right? It's not been replaced. उसने yes. हमने find नहीं किया. The problem is this. S3 dot find क्या करना है हमें? We have to find S4. What it will do? In string F3, it will search for S4 string, and wherever the first element is found, उसका address यहाँ पे आ जाएगा. Let's run it again. या था ना, this is a sample string. तो ये क्या आ गया? This is a sample. String जहां है, actually we are using two different functions. First is find. In string F3, we are looking for offset. Offset means address of string F4, that is string. So here, like you can look here, this is the third string. Here is the offset of that string. So that offset will become the starting point. From that starting point, it will replace these many characters, whatever is the size of string, with this string. So the final output is, this is a sample to demonstrate use of string. See, only one instance of string has been changed. Others are still there. So let's do it once again. Int offset is equal to find it. पहले हम offset देखेंगे कि कहाँ है. While offset is not equal to string, what was that? Okay, this is the last position of the string. It's a very high value and it's assumed that string size won't be that much. So here we'll write offset. And now all the instances of string will be replaced. What we have done, we have found the first offset of the first string. Using that offset, we will change it, and then we will look for the, we'll find the offset once again. Now it will search for the second offset and third offset and so on. It will go on. Now it will replace all instances of string in the string. As you can see, this is a sample to demonstrate the use of sample container. Hope it helps in learning samples. Strings का s नहीं उसने replace किया, सिर्फ string replace किया. So this is how we implement find and replace. I hope it's clear.
Yes, sir.
Yes,
ये
sir.
clear था
Yes, sir.
बच्चे? Okay. Find
Okay.
and replace हो गया है. Okay. Then next is insert. How to insert an element. Should I remove all this?
Yes, sir.
String s4 is equal to s3 dot insert. So we'll have to give a position jahan insert karna hai. For example, I'm giving 0, or it may be begin. Okay, 0, and insert kya karna hai? For example, I think, let's say I'm inserting this thing here, and after that we will print s4. It will insert some string or some character at a defined location. Mind it, it will not replace, it will insert, it will increase the size of the string. Now look at the third string. Third string is this. Its size is 97. When you will insert, its size will become 104. And what we have inserted, I think, so it's been inserted in the beginning, right? You can specify any position, it will be inserted there. For example, if I specify position some, say 12, and I want to insert this string, let's see what will happen. So at the 12th position, it will be inserted. So definitely the size of string will increase. I repeat, it is not replacement, it is insertion. Ye clear hai bache?
Yes, sir.
Yes, sir.
Okay. I'll share the whole code with you, don't worry. Then is reverse. We can even reverse a string. Let me write it here. Oh, sorry, reserve. It's not reverse, reserve. Reserve means reserve this much space for it. For example, I am writing 500. I have written s3 dot reserve. Now what it will do, it will reserve this much size for the string. Not only this much, it will increase beyond this also. It will increase the capacity of s3 up to 500. Rather, it will be a little more than 500. I think 511. Let's just see. Yes, here it is. After reserving this more space, total size is still 97 per capacity change ho gaya. Look at the capacity. It is 511 now. Clear, bache?
Yes, sir.
It
Yes,
is
sir.
reserve, means reserve some more space for it. Okay, then we have replace हमने कर लिया, find and replace कर लिया था. Okay, then
Yes,
we
sir.
have
Yes.
append. Let me write it here. String s4 is equal to s3 dot append. Here is the appended string. Let us write that. करके देखते हैं. Here it is. Strings तक s3 में था. Then here is the appended string. Since we are creating a new string from S3, we are creating a new string from S3. S3 string plus this will be appended. Appended means added at the end. That will become the size, and accordingly capacity will be calculated. So it will not be 511 now. Even if we are creating it from S3, the size and capacity will be according to the string that we are actually storing in S4. Like here, the size of string is 124 and its capacity is 127. Okay. Well, then last thing, we have discussed how to find and replace elements. Suppose we would just want to replace something. Now for replace, quickly we'll do it. We need to include algorithm. We'll be using an inbuilt algorithm replace for replacing the string. I'm storing some ABC, XXXX, and then replace from 0 or S1 dot begin to S1 dot end. क्या रिप्लेस करना है? कैपिटल X किससे रिप्लेस करना है? से कैपिटल Y. And then let us print cout S1 and then रिप्लेस हुआ. XX जहां भी था वो YY से रिप्लेस हो गया.
Yes, sir.
So this